All right, today, finding the molar mass of compounds. You already figured out how to find the molar mass of elements, which means you just look on the periodic table and you say, hey, right there, that number, the bottom number, the atomic mass. It's the same thing as the molar mass, except for the unit's different. So what we're going to do now is we are going to find the molar mass of compounds. Okay, so in order to do this, it's going to be 4 steps. Step 1, put a plus between the molar mass of every element. What does this mean? Find the molar mass of all these elements. So we have calcium here, nitrogen, oxygen, 3 elements. We're going to find the molar mass of each one of those, and we're going to put a plus between them. Sounds really difficult, I know. So here's our periodic table. Calcium, 40.08. So we write 40.08, then we put a plus. Nitrogen, memorize this one, 14.01. 14.01. Oxygen, memorize it, 16.00. 16.00. Add them all up. All right, that's where we go right now. Step 2, put parentheses exactly where they are. Do you see how there are parentheses right here, right to the left of the N, and right here, right to the right of the O? We're going to put those parentheses right there. Okay, step 3, put a multiplication symbol to the left of every subscript. So here are our subscripts. There's a 3 there and a 2 there. So to the left of the 3 would be between the O and the 3. So we put a times 3. Okay? To the left of the 2 would be to the right of the parentheses. So we put times 2. Then we're going to put it in our calculator exactly this way. We're going to type 40.08 plus parentheses. See how I've got a parentheses right here? We're going to put the plus and then we put a parentheses. 14.01 plus 16.00 times 3, because there is a times 3 right here. Close the parentheses. Times 2. Hit enter. There you go, 164.1. So the molar mass of CaNO3, 2, which is calcium nitrate, is 164.1. Let's do some practice problems. Let's go with lithium hydroxide. Easy one, LiOH. Lithium. Look it up. Oops. Look it up. It is 6.94. We put 6.94. Oxygen, 16. We already memorized that because we're smart people. 16.00. We put a plus between it. Hydrogen, we should memorize this one too. 1.01. So we put 1.01. We put a plus between it. Parentheses, none of them. Subscripts, none of them. So we put this in the calculator exactly as it says. We put 6.94 plus 16.00 plus 1.01 equals 23.95. That is the molar mass of lithium hydroxide. And we would put, the units would be grams per mole, or you might see it as G mole to the -1 if you take IB, because that's how they like to do it. But grams per mole, or you could just put G over mole. All of those are completely reasonable abbreviations for the units. Let's try another one. Let's do something a little harder. Let's make a compound. Let's do iron 2 phosphate. Okay, this one's going to get pretty hairy. So look up iron. Iron is 55.85. You should memorize that one. 55.85. Okay, next element. So we got iron, phosphorus, oxygen. Phosphorus, 30.97. You could memorize it or not. It's not really that important. 30.97. Oxygen, we already memorized, 16.00. Okay, we put a plus between them, just like we said we would. Step 2, put parentheses exactly where they are. So in this one, the parentheses are to the left of the P, so we put one right there, and to the right of the O4, so we put one right there. Step 3, put a multiplication symbol to the left of the subscripts. So we got the subscript on the FE is 3, so we put a times 3. I know it's kind of squeaking it in there, but we'll handle it. The O, we put a times 4. The 2 here, we put it in between the 2 and the parentheses, so we put a times 2 right there. 55.85 times 3 plus parentheses. Whoops, I screwed that up. I'm going to restart. So 55.85 times 3 plus parentheses 30.97 plus 16.00 times 4 parentheses times 2 equals 357.49. This is much bigger. And this is grams per mole. This is way bigger than the other stuff we've done. This is more than twice as heavy as calcium nitrate because these elements are a lot bigger. Your answer should generally be less than 1,000. Occasionally it'll get more than 1,000, but if you get an answer bigger than 1,000, you screwed up. Okay, redo it. Unless the elements in there are all actinides or lanthanides and actinides, or some of the huge metals like lead, and you've got lots of them, you're not going to get over 1,000. You're going to stay probably somewhere between, at the low end, 10 and the high end 900, unless the molecule or compound is super huge. Otherwise, your answers should be pretty reasonably in the hundreds at the most. If you get an answer bigger than that, you forgot to put the plus before the parentheses. That's the most likely cause. Okay, good talk.